this is. So in this, many are just totally depends on angular momentum, conservation of angular momentum. I said this one given. A uniform circular disk placed on a rough horizontal surface has initially a velocity v0 and an angular velocity omega naught, as shown in the figure. Fine. The disk comes to rest after moving some distance in the direction of motion. Then v0 by r omega naught they are asking. See, final angular momentum, what is the net angular momentum of the system? Consider the body. The initial momentum. Okay. Look at the initial momentum. The initial momentum is, so the momentum caused by the center of mass 1. Another thing, the momentum of inertia caused by the angular velocity. Some of these two, when you look at this on the center of mass, no, so one is negative, another one is positive. Okay, one is negative, means two angular momentums are there simultaneously, but the net angular momentum is the system's initial angular momentum. Okay, keep it like. The finally, there is no linear velocity and there is no rotational velocity. Understood? So now you can say the total angular momentum is 0. Now equate this is to 0. You will get such a nice equation very easily. Now finally, you can get v0 by r omega naught is equal to half. Fine. Where is the difficulty ones? You can check it. Okay. Next one. See, this is the 47th problem. Sorry for this. Why? Because while copying, it is misplaced. Now look at here. If the radius of Earth is reduced to 3/4 of its present value without change in its mass, then value of duration of the day of Earth will be. So here already, even in coming chapter, even we studied Kepler's law, second law. We proved that aerial velocity remains constant where the angular momentum conservation takes place. Okay, we proved also that is. Okay, now initial moment of inertia or the initial momentum together is equal to final momentum. Only here what is changing mass is remains constant. Only the radius of the body changes. While the radius of the body changes, one is small, another one is big. So now, initially it is this much radius. After 3/4 it will becomes 3/4 of the radius. So indirectly it is reduced. Yes, now 25% of the radius reduced. Now just substitute what is the sphere. If you take the sphere moment of inertia, 2/5 mr square omega. It's angular velocity, suppose initial velocity. Now then you can take 2/5 m r square. R is now changes 3r, 3/4 of the initial r whole square. Now you can get, now what is omega? Omega formula that is 2 pi by time period. Now place this formula for in the place of respective angular velocities before and after. So now you can simplify this, the ratio of t1 and t2. So now you will get 27 by 2 hours. Now 27 by 2 is nothing but 13.5 hours. So that is indirectly 13 hours, 30 minutes. Okay, fine. Now your answer is 13 hours. Now come to the next problem. So always whenever I am explaining these problems, remember that concept you need to slowly, you will get then clarity. That clarity is more important. Okay. Now once you look at this problem, what they given here, I clearly mentioned in the classroom. So before going to the exam also, this kind of problem compulsory they will ask, like a common angular velocity, similar to linear dynamics, where the momentum, sir, m1 v1 is plus m2 v2 is equal to m1 plus m2 into v. The similar problem I said, but no, why you've done mistake? Once you cross-check yourself, okay, where the mistake is gone. Once you look at here, what they given, simply initial mass, one body mass is m, and its radius is r. So very, very important task you need to know, either it is circular disk, what, why? Because you need to calculate the moment of inertia of that disk only. Don't take whatever the bodies you remember. Now when you are taking this in a horizontal plane, about an axis passing through its center, okay, and perpendicular to the plane with an angular velocity omega. Fine. What it mean indirectly? I1 omega they given. Fine. mr square by 2 omega given. Now the second body is at rest initially. So now it is not contributing initially for the angular momentum. Now after, when you place the second body, the rested plate with mass m by 2, okay, mass m by 2, but the radius they given same, another disk of same dimensions, okay, same radius, but only the mass is changing. Coaxially they placed one over the other. So already one is revolving, but the second one is you are placing over that. So now both, now you are with a common angular velocity they are rotating. Now see some of these two moments together, the system's moment, yes sir, moment of inertia. Now when you combine these two, you will get 3/4 mr square omega c. So this is why I am giving this symbol is common angular velocity. Now that common angular, just solve this, you will get how easily. Yes sir. Again come to that 28th problem is very basic. I depicted the example in the classroom also. When I am teaching the door, compulsory at the hinge, if I applied the force, it needed more force to move. Why? The reason is that the torque will be very less. The torque is the maximum force, rotational force. Yes, sir. So now if that rotational force is less, means it is very difficult to move the body. Yes, sir. In rotational dynamics particularly. Now, similarly, what they given, see, the torque is maximum at hinge. They don't know, never. Rotational force is not maximum at the outer end. When the distance increases, what the Galileo said. So, Galileo clearly mentioned when this distance is increases, then effort will be very less. Less effort is needed to move huge weight. Yes, sir. No, the similar torque is nothing but that is very, very important thing. So now, so the second option is wrong. That is at the edge, outer edge, it will be maximum. Yes, sir. Outer edge. That too, that must be perpendicular, not parallel. Okay. Parallel means again, what you will get? Zero torque. Zero torque. Now, why sin theta? Sin 180 is 0 degree. Now, this is a concept purely. So, assertion is correct, but reason is incorrect. Come to the 27th problem. And you look at the 27th problem. So, this is also on similar lines only, but in a horizontal plane, somewhere it is placed. Okay, anyhow, you can take anywhere. So, what they given once you look at here. Consider a uniform rod of mass m, 4 m, and the length L pivoted about its center. Okay, a mass m moving with velocity v, making an angle 45 degrees to the rod's long axis. And we rod's long axis. Okay, anyhow, along the axis, around rod's axis. Okay, collides with one end of the rod and sticks to it. Okay, the angular speed of the rod, mass of the system just after the collision, they are asking what is the angular velocity. Now again, here when you look at there, again the angular momentum only at the point of contact or the collision indirectly happening, angular momentum you can take. Angular momentum, initial angular momentum is r cross p. Now here r is L by 2, remember that, L by 2. The momentum either you convert it into effective momentum, mb sin 45, otherwise sometimes you can take this is L by 2 sin 45, L by 2 sin 45. While we define this angular momentum, we discussed this. No? You can write this angular momentum either rp sin theta, let us suppose. Here maybe this is p sin theta you can take, otherwise p you can take common r sin theta also you can take, r sin theta also you can take. So very, very important. Understood? You remember. So either you can take the effective length by using this, otherwise effective momentum. So both are similar. Now once you will get, once it strucks, now what is the total momentum of the system at that point of time? See, remember, so the momentum of the rod at the middle already we know ml square by 12, yes or no? Ml square by 12. So now the total mass 4m L square by 12 is the moment of inertia on its axis of rotation. And next again, the mass small m is also sticks to this with a distance L by 2. So that is the reason m into L by 2 whole square. So now that is the moment of inertia of the only the body which is stick for that. Okay, mass is m only. Now the total moment of inertia, you know, sum of these two, 7 by 12 ml square. Now you can, from this you can relate what is what they are asking, angular velocity at the point of collision, just when it is collided. So now omega equal to, you can write, you can send this is 6v by 7 root 2 by L. Yes or no? 6v. Now you can simplify this by, because this is 2 3s by root 2 times it will go now 3 root 2 by 7 v by L. Okay, understood? Where is the difficulty? Again you need to check. Now come to the 30th problem. 30th problem already given. I sent in the morning 25 questions, in that this is one of the question direct. Yes sir. I explained in the classroom also. Yes sir, no. So whenever this radius is fixed and the angular velocity is constant, so compulsory at the center angular momentum has same direction, same magnitude. Remember that. Otherwise go through this mathematical treatments. Once you look at this clearly you can understand. Okay, now come to the 31st problem. So here this is purely a conceptual already we explained in the classroom. Once you look at here, the option 1, sometimes this is the incorrect answer, the statement they ask now, incorrect statement. Now in this, the right statement first you can eliminate first, easy method. Yes, sir. Now look at here, the friction force on the disc is in the backward direction till pure rolling starts. Yes sir. If it is if pure rolling starts, until that frictional force is always acting backward only. We know that is correct. Now when you look at this, the friction force between the disc and the plank is kinetic in nature till pure. Yes, kinetic. Why? Because that is moving. Both will be moved. There will be a relative motion. Between the plank and the object. So compulsory it is a kinetic in nature. You can say that is also correct. the total momentum of the system, disk and magnetic, disk and Planck will be conserved. That is also correct. Now, when you look at the last one, see, the angular momentum of the disk about any point on the horizontal surface remains correct. That is wrong. Any point is not correct. Okay, point to point it will vary. So you can say this is wrong. Again, come here. This is also, this is V, this is R cross, yes or no? Sorry, R cross below. R cross below. Like this, both are positive, sir. Both are positive. Both are positive. When you are taking both are in positive Z, but one is given negative. So that is the reason we can choose this option is wrong. This option is wrong. Now, go to the next question. This question already we know. We derived the expression also in linear dynamics, where the I said compulsory they will ask. This is what of in the place of mass is its analog is moment of inertia. Moment of inertia v1 minus v2 whole square, I said, yes or no? So remember, this is very very important. Very important direct formula if you need. So go through the derivation again once. Come to this one, the problem number 33. Clearly see two identical hollow spheres. Hollow spheres means what is this? Moment of inertia. Moment of inertia. Immediately you need to remember this. Next, same height but different angles of inclination. Different angles of inclination. Same height means, see, when they will reach this, so the total potential energy is converted into kinetic energy. Now all are same bodies, so now they will reach with same kinetic energy. Same kinetic energy means they have same velocity. Same velocity depends on only the height and g. Okay. Now come to the distances. See, when you are looking at this distance, as the angle less, it must travel more distance. It must travel more distance. So that is the reason they took more time periods. As the angle decreases, it will take more time. But all will never reach the bottom at the same positions. Still, if you are taking very plain, how much distance it can travel to reach the same height, yes or no? So remember, here the time depends on the angle of inclination, but velocity depends on only the height. Only the height. So if the height is different, then we need to think different. Okay, the next question. See, this is a problem sometimes where this technique they are commonly using, that is killing of your time. See how many options you need to check, every option. So this kind of problem, sometimes don't waste your time, just leave it. Otherwise, one more method, the shortest method you need to use, that is elimination method. Commonly what we call elimination method, in the sense, sometimes choose some particular things. Suppose I will take here, heat is always generated, in which case once you check kinetic friction, compulsory, heat is always generated. Rolling with the slipping, compulsory. So now once you check, S must be have B and D, otherwise B and D must have S. Once B and D check, S is there, okay, all are available. Now when you take D, S must be there, D. You can eliminate these two, S is not there. Now this you can take S, S must be there. So here S is there, here S is there. So now you need to think in this, answer is there. In these two, the answer is there. Once easy, no? Already no need to worry about all this. Once you come here, what other things you need? First check D, kinetic friction. Once you look at that, S is there, fine. What other options are correct for this? So what other options are correct for this? So kinetic friction, once you look at this R, work done by friction may be 0. Work done, friction may be 0. And then Q, look at work done by friction, maybe less than 0. These options are also correct for this, but they are not given. So they are given in this. So now this is final answer. Like that, eliminate it, but don't check and everything, each and every point, means it will kill your time. Next, 36. Come to the problem number 36. So problem number 36 is logic if you use. Suppose don't waste the time basically sometimes. Why need? So the contact force from ground on rod just before and just after cutting. So that is the same only, same forces there. Why? Because that continuity, according to your mathematical concepts, where the continuity is there, so there both sides, this side and this is the boundary, no? At boundary condition both will be same. Boundary condition, commonly what we call, you can use that concept of mathematics, boundary condition, where at the boundary this side and this side having same nature. So now n1 is equal to n2, that is implies the ratio is same. So now that is a simple logic. If you can calculate, so that will lead to waste of time. Okay. Now sometimes this is the reason, if you really know the concept immediately, if you can able to imagine in brains, so now you can save a lot of time. Suppose some person is not that much used his brain, so now you simply follow the solution, you will follow. So of course ultimately you will get the same thing. Yes, sir. Now come to the 37, problem number 37. What they are asking here, A mass m supported by massless string, okay, wound around a uniform hollow cylinder. Immediately you need to know hollow cylinder means looks like a moment of inertia. Yes, ring moment of inertia m r square. Now mass m, okay, and radius r. If the string does not slip on the cylinder, with what acceleration will the mass fall on release? Suppose if you release this mass, you are holding, so after that it will get accelerated. Yes, sir, it will get accelerated. So now for this, what you need to take? See here again, the torque is we need to use. What is the torque equal to commonly? Torque equal to r cross f. R cross. How much force is acting on this? Simply the downward force is this, the radius is. Now r cross both are 90 degrees, r cross f, rf only. Now mg into r. So that is mg into r. Fine, up to there you are understood. Now that is equal to always moment of inertia of the system into its angular acceleration. So now when you look at here, if the body is here a small mass, the same mass, how much it can experience, how much moment of inertia, mr square. Similarly, mr square due to this what we call this is hollow cylinder. So now hollow cylinder and both are same. So now 2 mr square into alpha you will get 2 mr. Now here what are the things will be gets cancelled. Now after resolution you will get simply 2 times r alpha. Already we know there is a relation between linear acceleration and angular acceleration. Now substitute in the place of r alpha a, then they are asking this acceleration. Or with what acceleration the body is moving on leaving that body. Yes, sir, that is a base. Next, come to the 38th problem, number 38. Okay, see this is purely a rotational dynamics again. What they are giving, uniform circular ring of radius r, first rotated about its horizontal axis with an angular velocity omega naught, and then carefully placed on a rough horizontal surface as shown. Okay, the coefficient of friction between the surface and the ring is mu. So time after which its angular speed reduced to 0.5. So now initial velocity. Now final velocity formula you can use. Final velocity, initial velocity minus alpha t, and that is what v equal to u plus at formula. Yes or no? In case this is a synonym for the, but here deceleration it is reducing, they clearly mentioned, so you can use minus. Now from this the final is 0.5 omega naught minus alpha t. Now you will get what is the time moment? 0.5 means of omega naught by alpha. Yes, sir. Once you will get, but you need to get this alpha. What is alpha? Alpha, you will get the torque relation with moment of inertia. Sir, moment of inertia, that is I alpha. Now torque is equal to again the force into radius only, force, the frictional force. Yes, sir, mu mg. Now into what? This radius. Now that is torque here. That is equal to mr square alpha. Now once you will get alpha equal to mu g by r. Now substitute this value in equation 1. You will get omega naught r 2 mu by g. Okay, next come to this. This is also a conceptual question only. Work done by friction on a rolling body in case of pure rolling means, remember, so always not zero, always not positive, always not negative, remember that. So it may be positive, negative or zero. Already we studied, not only in this, in all cases we studied SN of frictional forces. It depends on the direction of the displacement and the frictional force acting. Yes, sir. Now in this case also similarly when you will get positive in the sense when the body is rolling downward. In such case commonly the frictional force is upward to the inclination, and when it is rolling upward, in such case the frictional force is always acting downward. Okay, now the work done in this case is negative, work done in this case is positive, remember that. Okay, but if it is an horizontal surface, if the displacement is zero, so one case it is zero. So otherwise sometimes with a constant velocity is moving, with a constant velocity means no acceleration, or indirectly no angular acceleration means again the angular momentum is constant. Constant. Now in such cases work done is zero, means the torque is zero. Torque is zero means work done is zero. Now again take this problem number 40. Two particles A and B of mass m1 each moving with velocity v. Hit the ends of the ring, reach its bar of same mass m and length L simultaneously and stick to the bar as shown in the figure. Okay. Now the bar is kept smooth horizontal plane. Okay, the angular speed of the system must be equal to what? This is the angular momentum. See, the angular momentum is equal to initial angular momentum is equal to final angular momentum. You need to know that. Once you will get to initial angular momentum. See, initial angular momentum, this is on the center, so it is sitting like this. Both are having the same forces in there. So thereby mv moment of S R, both are also having 90 degrees. So now momentum and that length, half of the length, okay, from the center of mass. Now that will give contribution by one body. Another body is also similar, but the angular momentum is same direction. Why? Because here this is the position vector and this is the velocity r cross v. R cross v means into the board. Again, if you take here velocity, this is the r cross v again into the board. So that is the reason both are in the same direction. So add up. Now that is equal to, again you need to know I omega. Finally they are under motion, rotational. So I omega will enters instead of linear velocity. Now once they are under rotational motion, again their systems moment of inertia you need to calculate. One is on this axis perpendicular to the length. What is that? M into L square by 12. For this mass, how much distance? L by 2 m. So now m L by 2 whole square moment of inertia of this mass. Again this mass moment of inertia m L by 2 whole square. Now if you add up, you will get the total moment of inertia is 7 ml square by 12. Now when you equate again angular momentum initially equal to angular momentum final. Now that we will get this relation omega equal to 12v by 7l. Next, see here 41 toppling effect on the toppling concept. Once you look at here, so now I said either conservation of momentum and toppling, this time maximum problem. Now again remember, when where the force is acting, first you need to find out on the center of mass. If it is an inclined body, yes, on the center of mass. Now the distance, you know, this distance is half of the height, h by 2. Now that is actually the torque, yes sir. Now the torque is mg sin theta h by 2. That is equal to force into force. How much am I here acting? Mg cos theta into this distance x, yes sir, or mg cos theta, sir, mg cos theta by this distance. How much? This distance a by 2. Otherwise, if you want this m acts for this length x length is a by 2 cos theta. Either you can use anyway, but I will take directly. Suppose this is the force, this is the distance. How much am I? If the total distance is a by 2, sir, a by 2 into this. So now multiply mg cos theta into a by 2. So now by equating this, you will get cot theta equal to h by a or tan theta equal to a by h. Now in the options they given theta equal to tan inverse a by h. Simple condition. Many times I discussed this one, yes sir, for horizontal of course. The angle means only angle will enter, only the difference. Now again 42 purely on conceptual. Remember here, by lowering her arms, means a girl or a lady, an ice skater is able to spin her body at larger angle. Yes sir, when you are suppose extended arms, you are being close, moment of inertia will be decreased. So thereby angular velocity is speeded up, increases. Now the second statement, angular momentum is conserved if no torque acts on that. Torque means if the net torque is 0, so certainly angular momentum is conserved. So everyone, we all know that. Yes, sir. From that net, whenever the net torque acting on any body is 0, then angular momentum will be conserved. Now come to the 43. Again on the similar, the gymnast curls. Okay, when the gymnast curls like this, suppose his head and his clothes, then legs and everything, so automatically he will rotate many times before landing to the swimming pool. Okay, remember that. So now curling reduces his moment of inertia and increases, so inversely proportional. When it is decreases moment of inertia, again angular velocity is decreased. So that is the reason. Is it? Okay, this is the reason. Both are correct. Now 43 finish. Next 44. If you take 44, see again a square plate is rotating with angular velocity omega about its diagonal. Fine. Now you know again initial momentum is equal to final momentum. Only the same concept. When you take here initial momentum means I omega. I is how much on this? First you need to know what is the angular momentum on diagonal. Ma square by 12. So once you will get this, so now the other things you can get. Yes, sir. So again where you need the angular momentum here by using parallelogram. This is ma square by 12 plus this is m. What is the distance between these two? These two between is a by root 2. So now a square by 2. Now if you simplify this, you will get 7 ma square by 12. So this is the angular momentum, moment of inertia on axis B. So now once you will get this, now equate that is I1 omega initial angular velocity, final moment of inertia into final angular velocity. Now we will get a relation omega dash equal to omega by 7. Now come to the 45, problem number 45. In this, a uniform cylinder of mass 2 kg and radius 10 centimeters rolls between two surfaces moving in opposite direction as shown in the figure. The angular velocity of the cylinder is angular velocity of the cylinder. So remember here what are the things you need to know. One is the topmost point is moving with 3 meters per second. The down one is moving with velocity 1. So now top one is always so linear velocity, yes sir, center of mass if it is moving this side, yes or no, the top velocity is moving, certainly it is moving in this direction. Now VC center of mass plus V rotational gives rise to 3 meters per second. So next VC minus VR. Why here VC and VR are opposite in direction? So here we need to get this resultant velocity because of this VC minus VR. Now if you solve this equation, you will get VC equal to 2 meters per second and VR is 1 meter per second. So what it means indirectly, at every point this is where 1 meter per second is, and this is VR. So in addition to that, what you need to get, that center of mass, center of. Now center of mass velocity already you get, that is 2 meters per second. Fine. Now you will get this. Come to the point what they are asking, angular velocity. When you are applying a force, yes or no, that force on the center of mass, yes or no, we are, yes or no. So we are acting at this point. Suppose you can take like this, yes or no. We are or here anywhere you can use at any point. Okay, mvr is equal to I omega. So with respect to VR, either you can take here or here anywhere. Now 2 into 1 into 1 is what? Velocity. 1 to R is 10 into 10 power minus 2, 10 power minus 2. That is equal to 10 power minus 2 omega. Why? Because mr square by 2 m given 2 kg. This is 2 gets cancelled. 10 power minus 1 meters whole square. So that is the moment of inertia of this cylinder. Now that cylinder moment of inertia is substituted here. So automatically we can calculate what is the angular velocity. How much it is? 20 radian per second. Now come to the next problem. See 46th problem. So similar problem already we done, but for angle they sometimes they ask for calculate this angle. Yes, no, but now they fortunately they need not ask that, only angular velocity they asked. So this is less than that problem. This is lesser difficult than that problem. Now come here. First initial momentum unit. Again the final momentum is again equal to both are same. Again conservation of moment. Now you can see initial momentum depends on momentum into the distance. See where initially this is at rest, it's not moving. This particle only moving with a certain velocity. When it hits, now at this point of hitting, what is the angular momentum? So this is Li equal to mvl. Yes sir. Now when you are getting initial momentum, just calculate that is. Suppose I will use its mass is 0.1, 80 degree meter per second. The length is given 2 meters. Now 16 units of angular momentum. Come to the final angular momentum. Final angular momentum is system has two masses. One is at the center of mass, SR only. So now the total mass is m. What is the moment of inertia of only rod if you take? So its momentum on this axis, SR, where it is rotating. SR, suppose it's on this, it is rotating. On this, like vertical, into the board or out of the board. An axis if you take. On that it is revolving. Now on the edge, you know its moment of inertia is ml square by 3. And again, if you take only the mass and its moment of inertia, mass into L square, the distance square. So you can use these formulas. Now substitute their respective values. 0.9 by 3 into 4 plus 0.1 into 4 L square, of course, omega. Now if you substitute all these things, you will get 1.6 omega units. Okay. Now equate this initial and final, you will get 10 radian per second. Come to the 47th problem. See, look at here. If the radius of the earth is reduced to 4, sorry, already we discussed this one. I can skip. 2 times it is actually copied. Next, this one is 48th problem. See, this is a little understanding you need. Sometimes sometimes they may give the mistakes also. Okay. Many ways they may ask. Suppose if you take a horizontal, suddenly there is an obstacle is there. Suppose a cube is going like this with a particular velocity. After hitting this one, if this block is more than this, it will never go upward. So sometimes then also it will go. It will reverse and fall down here. But when a small obstacle is there, if the huge body is moving here with velocity, suddenly it will fall down. Is that no? So when just it is hitting this obstacle or the ridge, now it will try to move in a particular direction. So on this corner, if it is a cube, Now on this edge, the body tries to move. Indirectly, the axis of rotation now for this cube is on the edge, on this edge. Okay, remember, on this edge. When it hitting, so now suddenly the center of mass is taking an angular velocity like this. That angular velocity they are asking. For that again you need, while hitting, what is the angular momentum? So on this edge, on that edge, if you take, say, one is on the center of mass. Sir, on the center of mass, it is 1 by 6 ma square, already we calculated, plus ma square by 2. Ma square by 2 is by the distance between the parallel axis theorem you can use. Okay, parallel axis theorem. The distance between these two is a by root 2. So a by root 2 whole square is by 2. So into mass. So now we will get 2 by 3 ma square. 2 by 3 ma square. Fine. Once you will get this. Come. Initial momentum is equal to fine. Initial momentum again. Okay. Remember how you can get initial momentum is mv. At what height it will be? At what height it is hitting? So a by 2 distance. So that is the reason you are using that momentum into the distance. Okay. They are of course 90 degrees they have. So no worries about that cross product. Now next I into omega. What is the, already you calculated on this edge, what is the moment of inertia? 2 by 3 ma square. 2 by 3 ma square you get. Now from here omega equal to what you will get, and substitute the velocity and the side a, what they given. Okay, then you will get 75 radian per second. Now, but actually they asked that is equal to 15 y radians. Then what is the value of 15? Now how many 15s are there in this? 5 are there. Sorry, I'm sorry. Wrong, this is maybe some confusion. Sorry for this. How many are there? 5 are there. Okay, 5 are there. See problem number 32. So in this they are asking which of the following statement false? It's a false statement for angular momentum. See, to calculate angular momentum, in between see the points BC, DA, AB and CD they given. Now, so solving all this may be a difficult task, but come to the directions. Once you look at this, see this kind of problems. Okay, so now I will do this by using elimination method. Okay, first you can come here. So B to C I am moving. So now the velocity direction is in which direction? Vertically upward. Now for this the radius is this. Now R cross V means in which direction it will be? Positive k, correct. Okay, but at C also you need to go at C also. So the direction of velocity is like this. So now again the R cross V means out of the board, out of the place. Out of the place means that is along place only. No, this option is correct. Now come to the second option. Where the second option, from where to where? D to A. This is. So when it's going downward, R is like this. R cross V is into the board. It's okay, given correct. Now when you come to the D to A, when you come to the here, so now A to B, the radius vector is outward, velocity is along x-axis. Now we are taking like this means, now what will happen? So R plus V minus. So now minus E, this is also correct. Now come to the last one. See here they given one is minus, another one is plus. Obviously on a line at 2 points, that will be different. See, so the same direction it must be. Once you look at here, C to D here the radius vector. See, now you can erase this. This is also 5 you can take. This is 5. Okay, 5 is your answer. Okay. Now finished. So that is what they are asking. The next 49th problem. If you look at here, the 49th problem is they given a solid sphere of mass 2 kg is making pure rolling on a horizontal surface with kinetic energy 2240 joules. The velocity of the center of mass of the, you know this formula, and directly you use this formula. Sun kinetic energy they given directly. There is nothing but this one. So now k square by r square for what? Solid sphere. That ratio you know, 2 by 5. Why? Because k square in the k square is 2 by 5 r square. Yes sir. What is the moment of inertia of solid sphere? 2 by 5 mr square. So in place of k square, what is there? So from that you can calculate the ratio 2 by 5. Once you will get 2 by 5 ratio, now substitute here. All figures are non-values only except the velocity. Now simplify, you will get 40 meter per second. Where is the difficulty? You need to think about again. So come to the problem number 50, last problem. A heavy wheel of radius. Okay, that is the wheel they given. Okay, wheel means what is moment of inertia? Moment of inertia not required here. Okay. I mean to finish, not required. Okay, no, okay, they're asking toppling concept. Now a heavy wheel of radius 20 centimeters and weight of 10 kg is to be dragged over a step of height 10 centimeters by horizontal force F applied on the center of the wheel. Okay, the minimum value of F. Okay, now look at here again the minimum force, and then even that the torque is 0, so just it will come as with not acceleration with constant velocity. Now see here, you need to know this is the step just 10 centimeters. So now where the force is acting on this, where the force is acting on it. So because of this, not this one. Now the torque. See the torque acting on this the height where exactly up to here it is blocked mass indirectly. So the total other things the force is only acting. Now this height unit, that is 10 centimeters. Now F into this height is equal to, already we know this relation for toppling, that is equal to downward force, but the downward force acting where with the distance. Now this distance, you know, this is 10, this is 20. Now the other side automatically you can calculate by using the Pythagoras theorem. So now you will get this x is 10 root 3 centimeter. Now substitute 10 root 3 here, and the mass of the ring and the g, and what you need to calculate that force. Substitute all the height also, you have 10 centimeters. Once you will get that is 100 root 3 newtons. But here what they are asking, either you know the kg weight meaning or not, they wanted to test. Kg weight means, remember that 1 kg mass weight. Okay, that is commonly what we call kg weight. So now 1 kg mass means 1 kg into g value how much, my mg. So now 10 newtons. 10 newtons force commonly what we call 1 kg weight. Now here 10 newtons separate, you will get left with 10 root 3. Yes or no? That is the reason 10 root 3 kg weight. Root 3 value, you know, 1.73 something. So now after rounding off, you will get 17 kg weight force needed. Okay, that is the minimum force needed. Okay, understood. So where the difficulty, once you check all the problems. Okay.